We started our physical geography concepts from Earth-Sun relationship, how Earth-Sun relationship and the Earth's optical path and its tilt in on its axis leads to the different climate and weather phenomena. Then we defined the different important parallels, their significance, why those parallels are there, what are their purpose. After that, we talked about the radiations. We talked about the conduction, convection, and advection, how less dense water will rise and more dense cold water will come down. It sinks. So rising, we linked it with less dense, and sinking, we linked it with more dense. Then we talked about the advection, which is the horizontal movement of energy. Then we talked about how to measure the radiation. We defined the difference between the low wave, short wave, and the long wave radiations. Short wave radiations, we said these are the powerful waves, and long waves, these are the less powerful waves. And how we will alter from short wave to long wave, it is through a process known as absorption. So whenever there is an absorption, energy is going to be absorbed and the result will be the less powerful wave or radiation. After that, we talked about the opposite of absorption, that is albedo. Albedo is the reflection, is the reflective value of an substance. So we define the more albedo or the more reflectance it will be, the less absorption and it will be a low temperature. Opposite of that, if there is a low albedo, that is a low reflectance, which means high absorption, it will lead to the higher temperature. And now we are going to start our discussion with the structure of atmosphere, and we can categorize the atmosphere in three different categories. The first category is composition. What it means is how our atmosphere uh, composed of, from which thing it is composed of. Second is the temperature. We define different shells of the atmosphere on the basis of the difference in changing or the increasing or decreasing temperature. So different shells will exhibit different properties with related to temperature, and finally it will be the function of that particular shell of atmosphere. So let's draw a table now and see how we can do it. We draw a table and we draw three columns. The first column is for the composition, second is for temperature, and third is for function. Starting with the first column, which is for the composition, we divide our whole atmosphere into two layers. The first, it would be the homogeneous, and second, it would be the heterogeneous. So homogeneous section of the atmosphere, it is where the gases, they mix well. That is how the living has been made possible in this section of the atmosphere where the gases mix well. Because when we inhale, we don't only inhale oxygen, but we inhale a mixture of gases, which is a mixture of nitrogen, carbon dioxide. Second section, it is the heterogeneous sections where the gases doesn't mix well. So now what will happen is when they don't mix within each other, they layered themselves as per the atomic weight. So the more heavier gas will be on the bottom, followed by the less atomic weight gases. So this is about the composition. Now we come to the second category of the structure of atmosphere, which is temperature, and here we see four major shells and three minor shells. So four major shells, 1, 2, 3, 4, and three minor shells, 1, 2, 3. And this is the surface. Let us draw some of the mountains and trees here. So the first shell or the first layer of atmosphere, we see decrease in temperature with increase in altitude. With increase in height, we see decrease in temperature. We call this layer as tropopause. troposphere. Troposphere. Right. Then we see this small shell, the minor shell, and temperature doesn't increase or decrease here, and it remains constant, or it remains paused. So we call it tropopause, pausing of temperature. So this is tropopause, that is TP. In second shell, we see the increase in temperature with increase in height. We call this as stratosphere. And again, we see a pause in temperature where we call stratopause, and we write it as SP. Third layer, we again see decrease in temperature with increase in height. We call it as mesosphere. And this minor layer we call as mesopause. Finally, we come to the thermosphere, and we put this dotted line because it is very difficult to measure the exact temperature at that layer because the gas molecules are very far away. So troposphere, we see decrease in temperature with increase in height, then tropopause, then stratosphere where we see increase in temperature with increase in altitude, then stratopause, again a pause in temperature, then mesosphere, mesopause, and then thermosphere. The average temperature in tropopause, it is minus 57 degrees centigrade. Stratopause, it is 0 degrees centigrade. You can see here we see increase in temperature from tropopause to stratopause. Mesopause, we get 97 minus 97 degrees centigrade. So this is how we divide the different layers of the atmosphere on the basis of temperature, whether temperature is decreasing or increasing. Now coming to the third column, which is the function column, and we define three shells here. The first shell, it is the troposphere and tropopause, and troposphere is the region where we see all weather phenomena. Weather phenomena like rain, snow. Tropopause is the place where all aeroplanes fly. Above that, we see ozonosphere. So this is the layer where we see a layer of ozone molecules, and the function of this ozone molecules are to absorb the incoming radiations of sun. So we will get into the detail of this when we will talk about the greenhouse effect and how the ozone molecules play their role in the absorption of the incoming solar radiations, ultraviolet radiations. As we have seen in our previous concepts, that whenever this absorption happens, whenever the absorption of radiations happen, it will lead to the higher temperature. A higher temperature will result from absorption. So similarly here, the ozone molecules which are absorbing the incoming radiations from the sun, it will result in the higher temperature, and that is why we are seeing from tropopause to stratopause in stratosphere an increase in temperature with altitude or height. So this is ozonosphere, and the final one we see ionosphere, where we see the charged particles, right? The charged particles which play an important role in the radio wave communications, and also in the North Pole and the South Pole we see the rings, the green color, the red color rings, because of the charged particles which are present in ionosphere. So this is the structure of atmosphere based on the composition, temperature, and function. Now we move to the next part of atmosphere, and that is the earth energy balance. The earth energy balance, and we will try to see it using two different scenarios. Two different scenarios. Scenario 1 and scenario 2. In common of that, we have our sun, the source of energy, source of insolation. The first scenario, we see ice, and we see insolation from sun. Insolation. Insolation from sun, that is the incoming short waves, incoming short powerful waves. Now ice is having high albedo. Now what this high albedo will do, it will reflect back the short waves, outgoing short waves, because there is no absorption here, so there will be no long wave transmission, but it will be short wave transmission. So it will be a outgoing short waves. So high albedo result in low absorption, further leading to temperature low temperature. This is the scenario one where we see the colder version of Earth. Now the second scenario where we have some trees, some houses. Okay, doesn't look like house, but and soil. Right. And again we have insolation here, the incoming short waves, incoming powerful short waves. Now it will be the opposite of this. We have low albedo. Low albedo, it means the more absorption, that is high absorption, and it will lead to high temperatures. So here we have incoming short waves, and then what will be the result? Absorption will happen, then it will be outgoing long waves, isn't it? Long waves, the less powerful waves, and here we bring in the concept of greenhouse gases. Greenhouse gases, CO2, methane, vapor, dust. The primary is CO2, which is the main greenhouse gas. So here are these greenhouse gases. Now what these greenhouse gases will do is they will absorb again these outgoing long waves, and again they will emit. We have incoming long waves, right? So these are the outgoing long waves. These greenhouse gases are going to absorb it, again going to remit it. So we will have further less powerful incoming long waves. So that is how this energy will be trapped in between. So this is the warmer version or the hot version, and this is the cold version. So that is how Earth is able to manage its energy. So that is how it is managing not to be very cold and not to be very hot. So here we have outgoing long waves as well. So here they are going to absorb certain outgoing long waves, then re-emitting as the incoming long waves to the Earth, but again emitting, or which are not captured by the gases, will be the outgoing long waves to the space. So here we see these two components, that is the outgoing short waves, this is the number one, and outgoing long waves. So that is how heat is going out from the Earth's surface and certain heat is getting absorbed. So that is how Earth is managing its balance, the energy balance. So in this figure we can see 30% of the total insolation are getting reflected and scattered by the Earth's albedo, 6% by atmosphere, 20% by clouds, 4% by earth, snow or sand. Then the rest of the 70% gets absorbed at surface and absorbed by clouds and atmosphere. So that is how the incoming solar energy is distributed, and then Earth is maintaining perfect balance between the incoming insolation and the outgoing insolation, that is the scattered or the reflected from the Earth. Now in case if we bring more greenhouse gases here, right, we'll bring more greenhouse gases here. So now what will happen is it will not allow this uh, outgoing radiations, but it will trap all this which has been emitted by the Earth's surface. It will trap all this energy and it will re-emit back as the incoming long wave, increasing the temperature of the Earth's surface significantly, which is leading to the global warming, or which will further lead to the melting of the polar fronts. So that is how we discuss the Earth energy. So we started with the uh, structure of atmosphere. We divide it into three different categories: the composition, the temperature, and the function. The composition, we saw the homogeneous and the heterogeneous part. Then the temperature, in this troposphere, it is increasing, it is decreasing with increase in height. Then tropopause, then stratosphere, where it is increasing with increase in height. That is the result of ozones which are absorbing the incoming radiations, then increasing the temperature. Then stratopause, then mesosphere, where again we see the decrease in temperature with increase in height. Then is thermosphere. Then we saw the function of this layers of Earth atmosphere. Then we talked about the two scenarios to discuss the Earth energy balance, how Earth is able to manage, like why it is not so cold or so hot. We saw the first scenario as the cold version, where we have high albedo substances like ice, and we see outgoing short waves. Then we talked about the incoming short waves and outgoing long waves, which are getting trapped because of greenhouse gases. Then we saw 30% of the Earth insolation, total insolation, which it is receiving, are reflected back to the space, while 70% are getting absorbed by the atmosphere and the cloud and the surface of the Earth.